Hi friends, very good evening. Very good evening to you all. How are you, my dear friends? How did you celebrate Diwali? I hope. Hi Jitesh, very good evening. Jitesh has joined. Still I am waiting for few more players. Jitesh, what was the development in physics in the last week? How many problems you have solved, Jitesh, after the session? Come se come minimum 30 to 40 per day, having average of 5 to 7. Yeah, how is the growth in physics? Confidence levels in physics. Hi Radhika, hello. Very good evening, how are you? So, how many exemplar problems you have done? Hi Vinayak, very good evening. After a 1 week long gap, really I am enjoying your association once again. Fine Vinayak, but I missed you all for the last 1 week. Because of Diwali festival, you were busy and I was busy. So after the vacation, today only I came to you. It's going higher, very good. Yeah. Kushi, aspirants, hoy arrow, namastina hai, kalsa, hame bus party, jana he bus, parte jana. Sir, ये गाना मैंने लिखा. Oh, fantastic, Kushi, fantastic. Really awesome. Fantastic. We are very lucky to have a poet like Kushi with us. Fantastic. Really awesome, Kushi. Very good, Gani. Still, yeah. So let us gear up for the program. And in the last class, very good evening, Kushi. A body of mass, question most students got wrong from the last CPP. A body of mass m falling vertically downwards under gravity breaks into two fragments or two parts. A body B of mass m by 3 and a body C of mass 2 by 3m, I mean more than B. Then center of mass of bodies B and C taken together shifts towards. In the center of mass conceptual points, I mentioned one point. Center of mass is always placed nearer to the body having more mass. According to that conceptual point, after breaking, center of mass will be nearer to the body having more mass. Among the two masses, one is having a value m by 3 and other is having a value 2 by 3m, which is double that of m. So obviously center of mass will be nearer to the Mansi. Hi, very good evening Mansi, how are you? After a long gap. So center of mass will be nearer to the body C. This is a very good evening Mansi, very good evening. This is the solution for this problem. Once again repeating, center of mass is always located nearer to the body with more mass. You have to examine among B and C which has more mass. From the given problem, it is clear that C has more mass, which is double that of B. Ultimately, center of mass is located nearer to the particle with more mass, that is C. I hope everyone has got the clarity. And just let us have a glance of the recap of the previous class. And we discussed with the discrete particle system In that I made you to solve different models of numericals, square, triangle, and along the x-axis, along the y-axis. Now, center of mass of the continuous mass distribution, I had introduced that concept, and after that numerical problems. And in the today's session, the goals are center of mass of continuous mass distribution, followed by numericals, followed by going to another one, motion of center of mass. And in the last session, I just introduced what is CMD, continuous mass distribution. Say for example, till now we dealt with the problems in which particles are placed at different locations in a different style, maybe assembling a triangle, assembling a square, or placed along the x-axis like that. All those particles are called as discrete particles, and when they are along the single dimension, nothing but one dimension, we computed the center of mass xcm having some equation m1 x1 m2 x2 by total mass. When they are arranged in a square shape or triangular shape, we dealt with the problem in which it is a model under center of mass of two-dimensional system. Now it is the center of mass of CMD. What is CMD? Any object having a definite size, definite shape, definite volume can be called as continuous mass distribution. Any object having a definite shape, a definite volume, having a definite mass is considered under continuous mass distribution. Sphere is an example of CMD. Sphere is an example of CMD. Rod is an example of CMD. Followed by cube is an example of CMD, etc., etc. Means all these objects are having their own shape, their own properties, and their own dimensions. They are called as CMD or continuous mass distribution. Now, how to handle the problems related to the continuous mass distribution? For a discrete particle system, we are having a xcm, ycm like that. But for continuous mass distribution, how to handle? The center of mass, x coordinate of the center of mass is given by integration of x dm divided by integration of dm. That is the x coordinate of the center of mass for continuous mass distribution. Y coordinate of the center of mass, integration of y dm divided by integration of dm. This is y coordinate of the center of mass. Z coordinate of the center of mass, integration of z dm by integration of dm. So, this is the way how to handle the problems. Hi Josna, how are you my friend? After a long gap of 1 week, I am finding you on the screen. I am fine Josna, how about you? No worry, don't, just you are late by 10 minutes only, it is not a big late, don't worry. So, we are having x coordinate of the center of mass, y coordinate of the center of mass, and z coordinate of the center of mass, basic equations. Now, how to handle the problems related to this? A simple narration. For example, I want to know the center of mass of this rod. I want to know the center of mass of this rod. The mass of the rod is capital M and the length of the rod is capital L. Now, take the help of the coordinate system. Paste the rod along x-axis. Rod is aligned along x-axis. After that, consider a small portion of the rod. this small portion is having a mass of dm and having a small length, that is nothing but dx. Dx is the length of the small element, and the small element is located at a distance of x from the origin. So you have to take the CMD, you have to select a small element, that small element has a mass of dm and that small element has a length of dx, and that small element from the origin is located at a distance of x units. Now I want the dm value. As per the equation, I have to prepare dm. dm is nothing but linear density of the rod. Linear density of the rod is nothing but mass of the rod divided by length of the rod. The linear density of the rod is nothing but mass of the rod divided by length of the rod. Then this linear density multiplied by length of the element, m by l into dx will give you the small mass dm. m by l into dx will give you the small mass dm. Radhika already announced the answer, 12 by 3. Let me explain one problem, then your racing problems I will give one by one. Yeah. So dm is equal to m by l into dx, and as per the formula, next dm is ready, and let us see the numerator, integration of x dm, that is nothing but integration of x into x is the position of that small element from the origin, m by l into dx divided by integration of dm, that is nothing but integration of dm. So when you go to this, when you simplify this, m by l is a constant, bring it out, m by l into integration of x dx is nothing but x square by 2, and you have to define the limits of integration. One limit is origin, other limit is l, 0 to l divided by m, m gets cancelled. So when you observe that, this will be equal to l square by 2l, l cancel, it is equal to l by 2. So l by 2 is the center of mass of the uniform rod. So this is the way how to deal the problems of continuous mass distribution. Brief recap, you have to, step number 1, you have to select a small element having a length dx, having a mass dm. After that you have to prepare the equation for dm. What is dm, friends? dm is nothing but mass of the small element under consideration. So that dm can be obtained by linear density m by l multiplied by length of the element. After that, third step is this one, finding the xcm. In the numerator you are having integration of x dm, and in the denominator you are having integration of dm. you have to redefine the limits. Lower limit is the origin and the upper limit is length of the rod. Now, this is the way, the procedure to be adopted for solving the problems of CMD. Shall we gear up for the racing problems? Racing problems are going to be commenced. If you are all ready, then I will start the race among you. A race for the week. Are you ready? Message me by. Message me. Problem number 4. Continuation of the last week. I am narrating the problem. Linear density of a rod of length 3 meter. The length of the rod is defined. Yeah, Radhika, dm is equal to m by l into dx. That only we have written. Dm is equal to m by l into dx. So here the mass of the rod is given as em. Length of the rod is capital L. Ultimately, when you refer the screen, step number 1 of the solution is indicating that only. Now, in this case, the linear density of a rod of length 3 meter changes. It is not a uniform rod. It is a non-uniform rod. How do we know? As x is equal to 0, what is the length of the rod? 2 units. In the denominator, it is integration of dm, because center of mass is nothing but our basic definition m1 x1 by m1. Finally, the answer should be distance only, not the mass. Got it? So, integration of dm. Here it is a uniform rod. For the uniform rod, you need not take m by l. Even if you take m by l, integration of dm. dm is equal to how much? M by l into dx. M by l into dx means what do you get? M by l being the constant. You can pick it out. Integration of dx is nothing but x. By substituting the limit, again you will get l only now. So here the linear density of the rod lambda is given as 2 plus x. Then the portion of the center of mass of the rod, the position of the center of mass of the rod, this is the question. Then the position of the center of, Radhika, got the clarity? You are asking integration of dm. Integration of dm is equal to m by l into dx. I know m by l is constant, bring it out. M by l into integration of dx, limits 0 to l. Integration of dx is x. I know m by l into x, limits 0 to l. In the place of x, you have to put l. Finally, you got m only now, Radhika. Integration of dm is m only now. Instead of doing this practice, direct integration of dm is dm. Got everyone? Got the clarity? If you say yes, then I will fire the problems. This numerical problem 4, you can have the glance. The linear density of the rod. Radhika, now you understood. Fantastic. Fantastic just now. The linear density of the rod. The length of the rod is given as 3 meter. Means the upper limit L is equal to 3 meter. It is varying. When the linear density is changing, it implies it is not a uniform rod. It is a non-uniform rod. They mention lambda equal to 2 plus x. Then the position of the center of mass of the rod is where? This is the question. Now your time starts. Gear up. I will see who will declare the answer very fastly and very quickly. Your time starts. Attack. Radhika, Josna, Mansi, Pratap Singh. You are all there, the prominent players of the show. Your time has started. The linear density of the rod is given and you are asked to find the position of the center of mass of the rod. This is the second model in the center of mass after the first models which we have covered in the last session. After the discrete models, now we are into the definite models, definite shapes called as CMD. So here the linear density of the rod is lambda equal to 2 plus x. The length of the rod is equal to 3 meter. Then I asked you to find the position of the center of mass of the rod. Your time starts. I will observe who will give the fastest answer. Eagerly waiting. Mansi, where are you? Everyone should present on the screen, friends. We are in the very important topic both for JEE as well as NEET. Center of mass followed by collisions followed by rotational dynamics. So what is the answer for this problem? First we have to prepare dm. After that throw that dm into our regular equation. What is the equation for CMD? Integration of x dm by integration of dm. In that equation you are supposed to put the data. Now after that you have to do the integration. As you are aspiring for engineering as well as medicine, you must be well versed with the calculus part, integral calculus as well as differential calculus. Now we are operating with the integral calculus. What is the answer? I am waiting. Josna, where are you? Radhika, Jitesh, Pratap Singh, Mansi, gear up for the answer. The time is running out. The time is running out. Make it quick. Make it fast. Yeah, Kushi declared the answer as 12 by 7. On the board it is not there. Kushi, on the options it is not there. Radhika also declared 12 by 7, but that option is not there on the screen. Kushi declared 12 by 4. Apeksha declared, oh, Apeksha has entered the game. Fantastic. Welcome to you, Apeksha. Have a nice evening, Apeksha. I am eagerly waiting for you. Apeksha entered the game with options only directly. Fantastic. She declared her option as a 10 by 7. No response from the boys. Response is expected from the boys. Wow, Swarnika, answer will be 12 by 7 meter. But 12 by 7 is not there on the board, Swarnika. Yeah, it is 12 by 7. It is wrongly typed. 12 by 7 is the second option. It is not 12 by 4. 12 by 7, 10 by 7, 9 by 7, 7 by 3. Now your time is up. 12 by 7 is the correct option. Fantastic. 12 by 7 as declared by Radhika, followed by Kushi, followed by Apeksha. Answer is 12 by 7. See, dm. dm is nothing but a linear density. Linear density is nothing but a lambda into dx. Then numerator, we are having numerator. What is that? Integration of x dm. Very good. Integration of lambda dx into x, because dm is equal to lambda into dx. Apart from that, we are having x also. 12 by 7 is the correct option. In the place of lambda, replace 2 plus x into x dx. Limits 0 to 3. Lower limit of the rod is origin. Upper limit of the rod is the length of the rod. 2 plus x into dx. That is equal to 2 into x dx plus x square dx. Limits 0 to 3, 0 to 3. Integration of x dx is equal to x square by 2. Limits 0 to 3. Integration of x square is nothing but x cube by 3. Limits 0 to 3. 2 to cancel out. Here x square is nothing but 3 square 9 plus this is 3 cube by 3. This is nothing but 9 plus 27 by 3, that is nothing but 9. So that is equal to how much? Numerator is equal to 18. And when you go to the denominator, once again see the numerator, lambda into dx into x, that is nothing but lambda into dx is the formula for dm. Dm formula, linear density multiplied by length of the small element. So in the place of dm, I replace lambda into dx. Apart from that, we are having x. What is x in our problem? Distance of the small element from the origin. After that, I open the integration. I got 2x dx and x square dx. 2x dx is nothing but x square by 2. 2 got cancelled. X square upper limit 3. Then you will get 9. When you come to the second term, x square dx equal to x cube by 3. X cube is nothing but 27 by 3, that is equal to 9. 9 plus 9, 18, that is the value of the numerator. And the value of the denominator, integration of dm hai na. In the place of dm, you have to write lambda into dx. Lambda is nothing but 2 plus x. 2 plus x into dx, that is nothing but 2 into dx, nothing but 2x plus x square by 2. That is 2 into 3 plus 9 by 2. 2 into 3 is nothing but 6. 6 plus 9 by 2. That is nothing but 2 into 6, 21. 2 into 6, 12 plus 9, 21 by 2. So final answer is equal to 18 divided by 21 by 2. 36 by 21. 3 goes 12 times. 3 goes 7 times. Very good, fantastic. Radhika got the first. So finally, what is the answer? 36 by 21, that will be equal to 12 by 7. Anyone has any doubt in solving this problem from the boys side? Any doubt in this problem? Shall I proceed further? So once again, brief recap. You have to frame the equation for dm. Dm is nothing but a lambda, linear density, into length of the element. After that, numerator n is equal to integration of x dm, that is nothing but integration of x into lambda into dx, and denominator capital D is equal to integration of dm, that is equal to integration of lambda into dx. Final answer, center of mass is equal to numerator by denominator. Just within 4 steps you are supposed to get. Now I am taking you to the next problem. The variation of linear density of a cylindrical thick and long rod is given by rho is equal to rho naught into x square by L square. I am writing the equation very clearly. Rho is equal to rho naught into x square by L square. Then position of its center of mass from x is equal to 0 end is. This is the problem. First option is given as 2L by 3, second option is given as L by 2, third option is given as L by 3, and fourth option is given as 3L by 4. Once again, the narration of the problem. The variation of linear density of a cylindrical thick and a long rod is given by rho is equal to rho naught into x square by L square. Then position of the center of mass from x is equal to 0 end. Your time has started. Attack Josna, Mansi, Radhika, Kushi, Somanika. Your time has started. Pratap Singh, Jitesh, where are you all? Come into the game. Show your presence. Dominate others. Your time has started. Attack. Apeksha, Waiting for your answer, Apeksha. For this problem, who is going to declare the answer first? Numerical problem number 5. Your time is running out. I am waiting for the answer. Make it fast. I am waiting for your answer. Friends, I am waiting for your answer. Who is declaring the answer? Same steps, similar steps. Integration of x dm by integration of dm. Selecting the small element, finding the mass of the small element, multiplying the mass of the small element with x, and the rest of the procedure you are well versed. Apeksha declared 1/3, Josna declared L by 3, Jitesh declared D option, and Radhika declared D option, Swamanika declared D option, Kushi declared D option, 3L by 4, Josna declared D option, and Jitesh density of girls is more in HashLearn. Fantastic. Jitesh noticed, Jitesh found out an innovative point. Density of girls is more in the HashLearn. Kushi, yeah, Jitesh, you are correct. So the right answer is 3L by 4. Option D is the correct option. Rho is equal to rho naught into x square by L square. Jitesh has declared the answer, the 3L by 4. Again see, simple procedure. dm is equal to rho naught into x square by L square into dx. That is the first step. Then numerator n is equal to integration of rho naught x square by L square. This is the value of dm into x. In this, rho naught and L square are constants. Throw them out. Rho naught by L square. You have to integrate x into x square, x cube dx is nothing but x to the power of 4 by 4, limits 0 to capital L. Then what do you get? Numerator value is equal to rho naught by 4L square into L to the power of 4, that is equal to rho naught L square by 4. That is the value of the numerator just now. This is the value of the numerator. Come back to the denominator. Denominator is nothing but simply dm, that is nothing but a rho naught by L square into x square dx, that is nothing but rho naught by L square, x square integration x cube by 3 followed by 0 to L. Then what do you get? Rho naught by 3L square into L cube, that is equal to rho naught L by 3. This is the value of the denominator. Numerator by denominator. Then what do you get just now? This is the numerator value just now, and this is the denominator value just now. What will be the answer, boss? Come back. I will write numerator is equal to rho naught L square by 4 and denominator is equal to rho naught L by 3. Divide numerator by denominator, rho naught cancel, LL cancel. This will be equal to 3L by 4. That is the reason for the getting 3L by 4. Josna, I hope now you got the clarity. I presented the step to step very clearly. Have a glance. Josna, got the clarity? If you got the clarity in this problem, Josna, you should be the winner for the next problem. I am keeping a lot of responsibility on you, Josna. Gear up and got the first position by overtaking Radhika and others. This is very mind blowing, hair falling, body itching. It is a hybrid problem. Numerical problem number 6. Have a glance. A thin rod of length capital L lying along the x-axis with its ends at x is equal to 0 and x is equal to L. Josna, very good. No problem, Apeksha. I know you are very capable. I know about each and everyone. Everyone in this show are not less for any other. You are equally competent. But only thing, I am putting you with more pressure and more activity so that in great hurry you may commit some silly, petty, naughty mistakes. No worry. You will all, fantastic performance is being displayed from you. A thin rod of length L lying along the x-axis with its ends at x is equal to 0 and x is equal to L. Its linear density varies with the position x as k into x by L whole power n, where n can be 0 or any positive number. If the position, this is not portion, this is position. If the position xcm of the center of mass of the rod is plotted against the number n, integer n, then which of the following graphs approximate the dependence of xcm on n? Dependence of xcm on n. A thin rod, these are all very high end problems. A thin rod of length capital L lying along x-axis with its ends, they have mentioned the boundaries of the rod. One end is at the origin and other end is at L. Its linear density changes as k into linear density symbol is lambda. Lambda is given as k into x by L whole power n. Jitesh, I need the mathematical proof. Whatever the answer we are all declaring, that should be supplemented by mathematical proof. And in this case, lambda is given this. If the position of the center of mass of the rod xcm is plotted against the number n being an integer, in which of the following graphs approximate the dependence of x center of mass on the rod? This is the problem, boss. Who is declaring the answer? I am eagerly waiting. Jitesh is saying D. Is it so? He is asking me. Radhika said D. Smarnika declared D. Josna declared D. Still any other answers? I am eagerly waiting for the rest of the answers. Jitesh, when n is equal to 0, center of mass is said L by 2. So Jitesh said n is equal to 0, center of mass is equal to L by 2. Still any other answers? I am waiting. Jitesh said when n is equal to 0, center of mass is equal to L divided by 2. Still any other answers? Josna sir, increasing graph as per you given. Increasing graph as per you given. Josna declared, sir, increasing graph as per you given. I did not get what is that, Josna? Narrate that. Still any other answers? Mansi, where are you? Mansi, Pratap Singh, Thakur. Fantastic explanations are given by my friends Radhika and Jitesh. Fantastic explanations. So, center of mass tends to L. When you observe this, the correct answer for this problem is answer D, as said by all of you. All of you came out with the perfect answers for this problem. As you said, we are having lambda given. Our regular procedure, attacking for finding xcm, then you will come out with integration of x dm by integration of dm. Then you will come out with some solution. When you observe the relation of xcm with respect to n, that is quite satisfactory for the fourth option. So, apply the regular phenomena, integration of x dm by dm, xcm, position of the center of mass. Yeah, Josna, you are perfectly well. Integration of x dm by integration of dm. Already you know dm is equal to lambda into dx. Here lambda is given as k into x by L whole power n into dx. This is the value of dm. Substitute here and do the integration, then you will get the same. Then problem number 7, linear density. Shall I am gearing up for this problem. Everyone done very nicely, boss. Really, hats up to you. Fantastic performance for this problem. All are appreciable. Everyone has done very nicely. Now, numerical problem number 7, mu is equal to linear density of the rod lambda into x square. Mu is equal to the linear density of the rod is given as lambda into x square, lambda being some constant. Then the distance of the center of mass of the rod from the end. This is the question. Distance of the center of mass. So, A is equal to L by 2, B is equal to L by 4, C is equal to 3L by 4, D is equal to L by 3. So, note down the problem. Mu is equal to lambda into x square, lambda being a constant, then the distance of the center of mass of the rod. I am giving contest question, no worry, I am giving. Current in LCR circuit becomes extremely large. For current to become large in an LCR circuit, impedance Z must be minimum. We know that impedance Z is given by root of R square plus XL minus XC whole square. Current I is equal to V by Z. As per this equation, I is a maximum when Z is a minimum. Z is a minimum when this second term is 0. Second term is 0 means XL is equal to XC. Circuit is said to be at a resonance. Circuit is said to be in electrical resonance. Then inductive reactance becomes equal to the capacitive reactance. Then impedance is purely resistive and is a minimum. And the winner of this contest, Jitesh D'Souza. Give me a big clap. Jitesh, superb performance. The winner of this contest question, Jitesh D'Souza, and he is eligible for a free atom session. Give our friend Jitesh a big applause. Give him a big clap. So that is a question, contest question. Everyone is eagerly waiting. Option C. is the correct option. And the contest question for the next session, the velocity of the center of mass of the system of two particles having the masses 1 kg and 2 kg, having the masses 1 kg as well as 2 kg. This is 2 meter per second. One only of the boy of the today's class, Sushant Sehgal. Congrats. Who is this new joinee? Sushant. Fantastic. Welcome to you, Sushant. So the contest time, it is a time of contest question. Option A 3i cap, option B 4i cap minus 3j cap, option C 2 plus 2 root 3 by 3i cap minus 2 by 3j cap, option D 8j cap. So there are two particles having the masses 1 kg and 2 kg. Their velocities with respect to the directions given. You are asked to find the velocity of the center of mass. So that was the contest question for the session. And when you observe the previous one, the question which I had just now given, the linear density of the rod mu is given by lambda into x square, the distance of the transfer of mass of the rod. Who did the answer? Who declared the answer for this question? The correct answer is 3L by 4. I think someone has already declared the answer 3L by 4. That is the answer for the numerical 7. 3L by 4, similar to the xdm integration by integration of dm. So that is the answer for this. What is the prize? You will get a one atom session free. Really great. Yeah. Now I have given beautiful number of problems for 10 problems for the passport people. So you have to get up for 10 numerical examples and try to solve them, because all are very, very fantastic problems covering multiple concepts. You have to set right your mind, you have to transit your mind very quickly from one problem to another problem, so that you will be able to solve the problems. And summary of the today's session: center of mass of CMD, center of numerical problems, and motion of the center of mass is given as a contest question, which we will see in the next class. And thanks for joining us. A fantastic performance by you all. In the next session, we will get up with the rest of the concepts of CM as well as the RM, and try to solve the passport problems which I had given. 10 numericals were given. Have a nice day. Thank you, Radhika. Atom session means you will get one session free, which you will get from our hash people. You will be intimated through message. Have a nice day. Enjoy.